In this video, we'll talk about alarms and events in industrial automation and explain their differences. In informal conversations, the terms alarm and event are often used interchangeably. However, in industrial automation systems, the alarms and events have a very specific meaning. In short, alarms indicate abnormal conditions to which an operator needs to respond. An event, on the other hand, is a state change that the automation system is interested in. Let me illustrate this with an example. Let's consider an oil tank with an inlet at the top and a drain at the bottom. So let's look at some examples for alarms and events for this tank. Examples for alarms could be that the drain is blocked, or that the tank is too full and overflows, or when it's totally empty. So basically it indicates that something is wrong. Examples for events are that the operator opens the valve or that the level threshold is exceeded. Basically, an event could be any state change that should be locked. We clearly see here the difference between alarms and events. An alarm signals that we are in a stage that we don't want the plant to be in. Hence, for each alarm, we can decide if the system is currently in this state or not. In contrast, events represent that some detectable change has happened, which may or may not be associated with an alarm. To summarize, the intention of an alarm is to signal that something has gone wrong, or that the particular stage of processing has been reached and that the operator needs to react to that. So for each alarm, we can decide if the system is currently in this state or not. Events, on the other hand, are represented by system status messages, and they do not require an operator response. They are defined as detectable occurrences, and they may or may not be associated with an alarm. So for example, that the operator opens the drain or closes the drain can be a totally normal event. On the other hand, it could also be associated with an alarm in case the tank is overflowing. Now that we have seen a couple of examples that are isolated but show what the difference between an alarm and event is, let's see how this works out in a whole automation system. So what we see here is basically the primary equipment in the field, and in addition we will have a PLC in the control layer, and on the supervision level we have our SCADA system. Remember, SCADA stands for Supervisory Control and Data Acquisition, and it is used for remote monitoring and control. One of its most important subsystems is the human-machine interface, which allows the operator to interact with the automation system. Often, open platform communication, in short OPC, is used to expose alarms and events to the SCADA system. The controllers, PLCs, generate and send messages to an OPC server when plant variables change. Using a common communication interface, one or several OPC clients can then subscribe to these alarms and events and be notified when they occur. Let's now look a bit into the internals of how the OPC server communicates with the OPC client and what happens where. Here we have the OPC server. Remember, it talks to the PLC to generate then events and alarms depending on what is going on in the plant. And we have the OPC client that talks to the OPC server. And contrary to normal data access in OPC, OPC alarms and events use the message passing paradigm. So messages are exchanged between the OPC client and the OPC server, and to make sure that the same event sequences and the same alarms are delivered to all clients, queues are used. So we have a queue at the OPC server that has one or more events, and it then sends these events and they are stored in queues on one or more servers, and this ensures that they are always in in the same order, and they remain in the queue until they are either read or timed out. Now we look at a few more details on how events are handled. Let's continue with the tank example. So we have tank, and we have here level switch. And now, how is this handled within the PLC? In the PLC, we have a function block for a certain event, in this case that the level is exceeded. Let's look at what happens in the PLC. Remember that in PLCs we can have function blocks that describe what happens in the system and how the system is controlled. So here we have a function block for event X. Let's say event X describes that liquid level has exceeded a certain threshold in the tank. And basically what this means that there is an input signal between the level switch and the PLC that enters the function block. And then of course we need to know at what time this happened. We also need to indicate the source of the event, and last but not least, the message that describes what this kind of event actually is. The output of this function block are any errors and the status of the event. And this status is then sent to the OPC server. So if we have here the OPC server, it will get notified and put an event into its queue, and then in turn notifies the OPC client. Okay, then let's see how this looks for alarms. And we use the same example with the tank, but now we don't have just an event that is basically a state change, but we have a whole state to represent. And actually this is done with the finite state machine that describes in what alarm condition we currently are. So again, we have the PLC, and now inside the PLC the alarm is represented by a state machine. I will just draw a couple of states and a couple of transitions between the states. And a state could, for example, be that the alarm is active, so the alarm signal is true, or that the alarm has been acknowledged, and so on. Now, this has a couple of inputs as well. First of all, the alarm signal, and this comes as well from the level switch. So, for example, we could have the alarm signal to be true if the level is exceeded or underrun. Then we have a signal that describes that the alarm is active, so that we actually check if the alarm condition is true or false. And last but not least, we represent whether the alarm has been acknowledged. And the output is simply the state condition. And here, let me repeat, it can be enabled, which means that the notifications will be sent. It can be active, in which case the alarm signal is true, and it can be acknowledged or not acknowledged, which means that the operator has responded to the alarm or not. So this, together with the message and the time, is sent to the OPC server. And just to remind us, we have a queue here, and then the OPC server in turn forwards this to the OPC client. And now comes the big difference to what we've seen on the event. Now the operator has to acknowledge the alarm, which indicates that the operator is aware of the alarm and either will take measures that are necessary or already has taken measures to deal with the situation. And this acknowledgement has to be sent back to the OPC server, and then from the OPC server back to the PLC, and at the PLC it can then change the acknowledgement into the alarm condition. Typically, there's also a button that can be pressed in the field that is also connected to the acknowledgement. And like this, the alarm can be either acknowledged in the operator room here, so on the supervision, on the SCADA level, or it can be acknowledged in the field. The last thing that I would like to say is that clearly whenever we have an alarm, that a bunch of events are generated as well. So every time the alarm condition changes, for example, if the alarm was not active and now is active, then typically an event is generated as well. And the event is treated as you see on the left on this slide, whereas the alarm itself is coped with the system as displayed on the right.